Hello. Oh, and welcome back. So in the last video, we were just kind of talking about the rules of analysis of variance and the things that we have to kind of check before we can properly do an ANOVA. And then we're kind of talking about how they are different than t-tests. Okay, and this idea of the null and alternative hypotheses being just slightly different than t-tests with one kind of tweak. Okay. So with that, we'll move on into an example, and we'll do it in R, but I want to give you the background first. So we have this, this little cutie here that is a part of the study we're about to look at. So some scientists reach out to you because they know how famous you're becoming and also how rich you are, and they ask you to analyze their data for them. And they have data of the weights of some rats. This little cutie here is just one of them. They have the weights of these rats, and these rats were given 4 different diets. And essentially, they just want to figure out, well, what diet leads to the biggest weight gain, or maybe the largest weight loss, the most weight loss. Okay, whatever their question is, we just want to see, is there a difference between any of these groups here? And by how much, okay? Or at least what range can we get for the whole population of rats, okay? Following these diets, okay? So we'll move on into R, and you will get a better idea of what the data actually looks like. So we're working with one-way ANOVA here, but the first thing I want to do, first I'll give myself some room here, is I want to make sure that we've got our data in here, and we're going to be working with this rat.csv file. Okay, so let's go ahead. I haven't even checked to see if this is like totally clean. It may not be. I'm going to call this data set rat. You could call it whatever, but just so I know what it is. And I'm going to read.csv, CSV. Okay, I'm going to pause the video and just do this. So I'll be back in a moment. Okay, I'm back. So I read in the data with the read.csv. It's in my working directory here. Some weird stuff went wrong with the column names. We have this kind of weird character here. Again, not a big deal. I just use the names column and specify the names that I want, the list of names that I want, and I am good. Okay, so we have our weight here in the first column. Okay, so column 1, and this is in grams, I believe. And so we see that we have 40 measurements here. And then we have our diet, okay? So we have beef with a low protein. So the source of where the protein is coming from and how much protein there is. Again, this is on them. This is how they did it. This is how they stored the data. Whatever, no big deal to us, right? And then we have beef with high protein. So where the protein came from and how much. And then cereal, same deal, with high and low protein, right? So we kind of have the vegan option and the non-vegan option, right? That's kind of the deal here. Maybe vegetarian. We'll say vegetarian. Anyway, so we have 4 different groups that we want to compare, okay? If this were just t-tests, we would only be able to compare 2 groups, okay? But we have more than 2 groups, so we need to do an ANOVA. The first thing we should do is we should check out how our data look, how they are behaving, just to get an idea of what exactly we're working with. So we'll write up some summary functions. If you want to pause the video, I am. You can write out this yourself, but what I want to do is I want to do a summary on the whole data, and I also want to do a summary by group. Okay, and so we've seen both of these before. This is just a little hint, going to be a single line. This is going to use that group by function that we saw in the last few examples. So I'll go ahead and pause the video and you'll see the code magically appear here in just a moment. Okay, I'm back. So I've got the code here for the first type of summary, okay? And here is one thing that I noticed that I need to do. So when we run that summary function, we get what we're used to seeing for this, for the quantitative variable here. We get the minimum value through the maximum value and all the summary stuff in between. However, right now, R is not realizing that the column of groups is a factor, okay? It's just reading it as a character. So just one really long string of text in here, and we don't want that, right? So we want R to realize that diet is made up of a bunch of different levels. So I run this as.factor back to that column of data. I run that, and then booyah. So now let's just take a quick look. We have a mean weight of 87.25 grams and 88.5 for the median. Sort of a nice thing about this is that if these two values are close together, like very similar, in this case, they're less than 1 unit away from each other, we can kind of already get an idea of the overall sort of shape of the data. Since these two values are so close together, this distribution may follow a normal distribution. Again, we don't really care so much about this distribution because we know we have a fairly large sample size. Okay, but just a little fun fact: if the mean and the median are close together, that means that those two things sort of indicate that this may follow a normal distribution. Again, not totally necessary. But we do see then counts for each group, each level. Okay, so we have our factor of diet, and then we have 4 different levels here, made up of 10 things in each, right? And then these 4 10s add up to be 40, right? So this is all good, okay? We don't have any extra rows or columns in our data set, everything there. After running line 5 and line 12 here, everything is clean from our data, which is great. Okay, so we have an even number of rats in each group. We don't necessarily need them to be an even number or the same number per group, but it is nice. So thank you, scientists. Okay, so with that, we'll go ahead and summarize by group, and I will pause the video again, just so you don't have to see me type, and you'll see me, in just a moment. Okay, I'm back. So I've got the code here written for summarizing by groups. Of course, the first thing I want to do is load in the tidyverse because I'm going to be using these sort of native functions to the tidyverse. I should get in the habit, and I think in future videos I do. I say that because there are already future videos made. It's always a good habit to have, this just read in at the top, whatever, just out of, convenience. Okay, so anyway, so I've got that read in, and I've got the data, and then I want to group by diet, okay, and that's just matching the same name as the column name here, and then I want to summarize. If you're looking at the PowerPoint, this code is there. I didn't ask for anything. I didn't actually ask for anything, but typically the mean and standard deviation is fine. You could report the median if you wanted to. You could do the whole min, first quartile, median, third quartile, that whole thing. But for right now, this is good for us. So if I run that, I've got it saved as a thing. I don't necessarily need it to be saved here, but I do like to have it just sort of conveniently there. So I don't have to run this whole chunk again. Okay, so let's take a look at what this is saying. So with the beef with high protein, so the source and how much protein, we have a mean weight of 100 grams with a standard deviation, so an average sort of moving around the mean of 15.1. So of the 10 rats in there, in this group, their average weight was 100 grams, but varied by about this much, okay, on average. And then the same can be kind of said here. So already we get an idea of how different these diets are and their weights, right? How much these different diets affect the weight. We see that cereal and low protein, so the source of protein being cereal with a very little amount of protein has, let's see, no, actually this is the smallest one. So beef with low protein has the smallest weight, okay, but varies by 13.9, right? So does that overlap mean that, these 3 groups might be the same, and then this group here is the one that's different from all the rest? Well, we won't know until we run an ANOVA, but we can already get an idea of sort of the amount of information overlap between these groups, right? And now another thing too is that we wanted to test, or at least we wanted to check the sort of consistency of variance between each of these groups. And since the standard deviations are around the same value for a lot of these, we might be able to infer that they are consistent enough for us to allow us to do an ANOVA. We have another test though that we can check. Okay, so this is always a kind of a good eyeball check, but we'll do an actual analysis on that idea of homogeneity of variance between groups. Okay, now the next thing I want to do is I want to visualize the differences. Okay, now I'm going to use the tidyverse and I'm going to use a box plot to do that. So I'll pause the video just so you don't have to see me type. But that's the old clue there. We're going to be using geom box plot and stat box plot to visualize at least the overall kind of shape of each one of these groups. Okay. Again, we do not have to manipulate the data because we already have our x-axis, or what we want our x-axis to be right here, already organized for us. And then our y-axis is right here. So no need to shift this around at all. Okay, I'll pause the video, drink some water, good Lord, and then you'll see me in a second. Okay, I'm back. So I've got the code here, the Ggplot code written. We'll just take it one thing at a time, just again, so we can kind of get an idea of what we're doing, what each one of these little components does. Feel free to skip through this if you want. I totally get it. So we've got our base layer here with our data, that is right here, with our x-axis, the diet, and the y-axis of weight. And if I run that, see, we get the blank slate, and then stat box plot just gives us the error bars, right? So totally blank with no box in it. And then geom box plot plots the overall box on top of it with the median line here. And then we know, just as a little recap, this is the smallest value. We have no outliers because there's no dots. This box here represents the 25th percentile, median, 75th percentile, and then the maximum value. So that's what that means. Everything below here is within the 50th percentile. Everything above this line is in the upper 50th percentile. Okay. Same, and then the same is said for all the other ones too. I use theme black and white this time, just because I kind of want to keep the tick marks back here, the kind of secondary lines, and then I wanted to rename the y-axis just to give it a unit. The data we have is pretty clean as far as the column name, so we don't have to necessarily tweak anything in here, which is cool. So I run all of that, and let's see what we're working with. And then we'll move on to a proper ANOVA, and we'll go from there. So already, and let me do this too. Let me run that line so we have all of that. So check it out. Check it out. So we have our beef with high protein right here in the first sort of position. We see that this kind of behavior here is reflected in the box plot. This beef with high protein may be statistically significantly different than these other ones. Now, again, if I recall correctly, that may actually not be the case. There might be enough overlap between this group and all of the other groups. We kind of see that here, that it may not be statistically significant, but we'll test that. Okay, but already, this is kind of surprising, or at least maybe this is kind of surprising. The fact that beef with low protein, cereal with high protein, and cereal with low protein are all around the same kind of area here on the plot. They have a lot of the same measurements for weight, and they're therefore also sharing some of the same information. Again, we'll test that in the future when we do an ANOVA, but figures kind of lead us to at least expect what the analysis gives us, okay? So figures are surprising, right? Figures are surprising, plots are surprising, but analysis should not be, right? So we should, in our analysis, see that, at least one of these groups may be statistically significantly different, and then we'll move on from there, okay? So this is always the good workflow. Read in your data, obviously, rename the columns if you need to. Make sure that everything is, let me do this too. Make sure that everything is properly stored. So let me just reread this in. I run summary, whatever. I hit the structure thing, and we see that it's being stored as a character. Okay, that's always good to check. Always check the summary and structure of your data set. Report it if you want. When we're working with groups, it is not necessarily the sort of interest in looking at the summary measures for all of the groups with like as in one big group, it's always good to kind of separate things like this. So that's the general workflow. And then after you do that, go ahead and plot the stuff just to see what we're working with, and then move on to analysis, which we're going to do right now. So with that, I will see you in the next one.